Welcome back to the deep dive. Our mission today is pretty specific. We're diving into a particular stack of source material all about professional audio-video distribution.
Yeah.
Yeah, we're not talking home setups here. This is the big stuff, the tech behind massive commercial displays. Today, we're really getting into 4K 30 Hz AV-over-IP Matrix switchers. We're looking specifically at systems that can handle, say, up to 30 TVs, maybe even more.
Right. And this is, well, it's a really critical area right now. This technology is essentially the backbone for any large modern display setup that needs flexibility. Think command centers, routing dozens of feeds instantly, or huge corporate buildings, big sports venues, places like that. The real shift, the key thing, is moving away from those older, fixed, physical matrix boxes, the ones that might limit you to, like, 16 inputs and 16 outputs. Now it's all moving to software, to network systems, much more adaptable.
Okay, let's jump right in with an example. We looked at a WolfPack 14 by 32 system. It's 14 transmitters, TXs, and 32 receivers, RXs. And here's a really practical detail. The source material says the TX and RX units, they're actually the same physical device. You just tell it what job to do in the software. Input or output?
Yeah, that's brilliant, actually. It sounds simple, but the practical side of that is huge, way beyond just, saving shelf space.
Yeah.
Imagine you're an integrator. You're managing maybe dozens of these across different sites. Having just one SD, one type of box to order, track, and stock. That's a massive simplification. If a unit fails out in the field, the tech doesn't need to wonder, do I have a spare TX or an RX on the truck? They just grab one box. It cuts down inventory hassle, makes buying easier, and critically speeds up replacement time. That's the real insight there, I think.
Efficiency through uniformity makes total sense.
Okay.
So let's talk tech standards. How does this flexibility scale without needing, crazy extensive gear?
Well, it's interesting how much performance they get out of what's basically standard networking. The sources confirm it delivers 4K resolution at 30 Hz. Which is honestly a great standard for most commercial uses, and it all uses AV-over-IP PoE technology.
PoE, power over Ethernet. So the receiver behind the TV gets its power and the video signal through the same network cable.
Exactly. One cable does both. That means fewer power outlets needed behind every single screen, simpler wiring.
Which has got to be a big cost saver operationally when you've got, say, 30 or 40 screens mounted way up high on a wall.
Absolutely. And getting that 4K video signal moved around efficiently relies on the compression standard. H.265 is basically like a very clever video shorthand. It shrinks that huge 4K signal down so it can travel over a standard 1G network switch.
Wait, did you say 1G? As in gigabit Ethernet? The kind most offices already have?
That's right, standard 1G.
So you're specifically not needing to upgrade the whole network backbone to expensive 10G or 40G just for video.
That's pretty much the main reason AV over IP is taking over in the commercial world. You're potentially saving tens of thousands on network hardware. Because the standard gigabit switches, which, like you said, you probably already have or can get relatively cheaply, can handle the load, thanks to that H.265 compression.
Okay, and compliance. The sources mention HDCP compliance and SEC security compliance. What do those actually guarantee for someone setting up, say, a control center?
Right, so HDCP is basically the copyright protection. If you want to show things like movies, cable channels, maybe even some protected corporate feeds, the system has to be HDCP compliant, otherwise blank screen. And SEC security compliance, that goes further. It's about reading stricter standards for data isolation, who can access what, network security. It's non-negotiable if you're handling sensitive financial data or, mission-critical information. It's a step above basic consumer stuff.
Okay, let's shift to the practical install side. We know it uses standard CT6 cable, easy enough.
Yeah.
And the signal distance. The sources say up to 450 feet on that same copper cable.
Yeah.
That's impressive. I remember just a few years back, getting 4K that far usually meant fiber optics, maybe complex power injectors.
It really is a big deal. The fact that standard Speed 6 can do it now simplifies installations and cuts costs significantly. It's a quiet revolution, really.
The infrastructure simplicity is key. But,
Yeah.
okay, 4K at 30 Hertz.
Yes.
I was going to ask about that. 30 Hertz is fine for, say, digital signage or corporate dashboards. But what if you're looking at fast-moving stock tickers or maybe security camera feeds? Relying on 30 Hertz and that H.265 compression introduce any noticeable lag or visual artifacts compared to an older, uncompressed system?
That's a fair question, and a necessary one. Look, for most commercial viewing, 4K 30 Hertz is absolutely fine. We're not talking high-end gaming here. But yes, if you have extremely detailed, very rapidly changing graphics, you might perceive a difference compared to, say, uncompressed 60 Hz. But the trade-off is massive cost savings and that incredible scalability. And speaking of responsiveness, the latency is actually very low. The system specs, quote, an 80 millisecond switching and latency time.
80 milliseconds. Okay, what does that actually feel like if you're the operator switching between sources on 30 monitors? Is it instant enough for critical stuff?
Oh, yeah. For human perception, 80 milliseconds is effectively instant. You won't see any noticeable delay or stutter when you switch sources. That speed is a really big selling point, especially compared to some older, clunkier IP video systems. Huge improvement.
Right, and this leads us to how you scale beyond those 30 TVs. If the network is the highway, how creative can you get with routing?
Well, because it's all built on standard networking principles, the system supports cascading multiple Ethernet switches. You can just link switches together as you grow. Connect that to the bigger idea. The sources state the system is designed for, essentially unlimited sources, unlimited HDMI ins, unlimited HDMI outs. You're completely freed from the physical port limits of a traditional box.
And that freedom really delivers on the main promise of these IP systems. Any in, any out, any way you want. It's all software control, deciding where the signals go. And it's not just video routing, is it? These systems pack in more functionality, like 4K 30 hertz live streaming support.
Yep, right out of the box. You can integrate web-based content easily. And for corporate or maybe government control rooms, the KVM support is massive. Keyboard, video, mouse. It means one operator at one desk can remotely control dozens of different source computers, servers, workstations, whatever they might be.
So one person could manage multiple machines, switching between them without physically moving,
Yeah.
turning a control room almost virtual.
Exactly. That's a huge workflow benefit in those environments.
Plus, it mentions separate audio outs, so you can route sound independently from the video signal if needed.
That's right. Gives you flexibility for different audio zones or specific sound requirements. Now, video walls. That's often a complex piece in big installations, right? Lobbies, conference centers, usually you'd need dedicated, often expensive video wall processors. But here, it seems integrated. The sources really emphasize that this system supports multiple video walls, any size, any quantity.
How does it pull that off without specialized hardware boxes for the walls?
It's all handled in software. The network moves the video, and the software intelligence in the receiver units does the stitching and scaling needed to make one big image across multiple screens. And that software approach is also why it has, as sources say, unlimited field upgradable capabilities. You're buying infrastructure that can adapt, not just a static box.
Okay, this is where it gets real for the person actually using it day to day. The control, we've got the hardware, the network. How do you actually manage this whole thing?
Right. The control side is purely software. You can use apps on iOS or Android tablets. There are PC control interfaces, standard Wi-Fi apps, lots of options.
But the feature that sounds absolutely critical, the one that must cut down on errors and big setups, is the iPad real-time video preview.
Yes. That's huge. Imagine you've got, 50 sources plugged in. Instead of just switching based on a label like Camera 3 or PC5, you can literally see a small live preview of what's on source, #15, right there on your control tablet before you send it live to the big screen.
That must make operating large venues or control rooms so much simpler. Less guesswork, fewer mistakes.
Drastically simpler, yeah.
The Force docs give a great concrete example with the optional sports bar system features. It might sound specific, but it's a good illustration of that granular control. You picture the floor plan of the venue right there on the tablet, and a manager can tap a TV on the plan and instantly change its channel. DirecTV, DISH, cable box, even Roku. Not just change channels, but route any channel source to any specific TV, all visually based on the floor plan and seeing the channel listings.
Exactly. And you can see how that floor plan interface translates directly to, say, a corporate setting. Maybe it shows server racks or data center layouts or even different building locations. It lets the operator manage inputs and outputs based on their physical context, not just abstract names or IP addresses. And yeah, audio controls built into that interface too. Different zones, different volumes.
Connecting this back to the supplier context, the sources point out the company's been around a while, 24 years in audio-video, certified since way back in 2003. That track record matters in tech.
It does. And maybe the biggest long-term win for you, the buyer, is the point about no monthly license fees. Think about it. You potentially avoid the big costs of 10G network upgrades, and you avoid ongoing software subscription fees. That makes the total cost of ownership, the TCO, much lower and way more predictable.
Okay, let's ground this with some numbers. What's the scale and cost look like based on the documentation? The base unit, a single 4K 30 Hz AV over IP PoE transceiver, remember it can be TX or RX, is listed at $250.
Right, that's a building block.
But when you build out a full system, it adds up. An 8 input by 22 output switch config, that's listed around $8,925. A bigger one, maybe 10 inputs by 30 outputs, comes in around $11,425. And importantly, they stress you can build your own custom system, BYO,
Right.
which is key for places that don't fit those standard sizes.
Yeah, that modular pricing, build as you go, perfectly matches the IP approach. You pay for the ports and the capacity you actually need now, and you can scale it up later bit by bit instead of a huge initial investment in a fixed box you might not even fill up.
So the big takeaway here seems to be the power of sending good quality 4K 30Hz video squeezed down efficiently with HDTV over your standard existing 1G network. It unlocks this incredible scalability, keeps the overall cost down, and gives you super flexible software-based control over where everything goes. Those old limits of physical boxes and expensive specialized hardware, they really seem to be fading away.
Absolutely. It's a fundamental shift. And if we circle back to the real world side of things, deploying this, given that it relies on that H.265 compression and the XTCP for protection and the SEC security stuff to work reliably at scale, it does raise a practical question for you, the implementer. When you're setting up a large system like this, which factor becomes the more critical bottleneck to really manage and test carefully in a busy real world environment? Is it that super fast 80 millisecond switching speed, or is it hitting the limits of that 450-foot signal distance over CT6? Which one needs more careful planning in a high-traffic commercial space? Something to think about for your next